Hello, this is my introduction video for the Geometric Analysis Past, Present, and Future online asynchronous event. My name is Spiro Karigiannis. I'm a professor in the Department of Pure Mathematics at the University of Waterloo in Canada. I'm a differential geometer and a geometric analyst, and I mostly study Riemannian manifolds with special additional geometric structures on them, including the special submanifolds and special connections in that context. The purpose of this short video is to give you a brief introduction into what I'm going to talk about in my lecture. I'm going to state vaguely, very vaguely, two theorems, and I'm going to talk about these theorems in detail during my lecture. So here's the setup. We have a smooth N manifold, and we fix an embedding Lk into Mn, where this is a k-dimensional compact oriented manifold. Of course, k is less than n in dimension. And the idea is the following. If we had a Riemannian metric on M, of course it induces a metric on L by restriction, and because L is oriented, we get a volume form on L, and because L is compact, we can integrate that volume form over L to get the volume of L. So we have a functional which takes a metric on M, a metric upstairs, and gives us the volume of L with respect to G restricted to L. So it's the integral, it's the integral over L of the volume form of L. This is, the embedding is fixed here. We're not varying that. And we're thinking of this as a functional of the ambient metric upstairs. And we have the following theorems. Theorem A, suppose L is calibrated with respect to some calibration form upstairs, then G is critical for this functional V with respect to variations of a particular special class of G of a particular special class. And I'm not going to tell you what this means. This is related to the calibration. I'll tell you, of course, in my talk. And theorem B is essentially a converse to theorem A. It says if G is critical for V with respect to certain special variations, then L is calibrated with respect to alpha. Okay, so I'm going to talk about these theorems in more detail in my talk, and I'm going to explain really what's going on. There's going to be four main cases. There are going to be the complex submanifolds of a Kähler manifold. There's going to be associative and co-associative submanifolds of a G2 manifold, and then Cayley submanifolds of a spin 7 manifold. And the theorems are a little bit different flavor in these four cases. So I'm going to explain all the sort of technicalities and go through at least the details of one or two of the proofs if I can. So I hope to see you at my talk virtually. Thank you.